Hello children, welcome back to physics class. I hope you're all doing well and ready to learn something new today. Well, in today's class, let us learn something interesting. It's all regarding the fluid pressure. So what exactly the fluid? What is meant by fluid, children? Anything, any substance which can flow are called as fluids. As we know that gases can flow, even liquids can also flow. So gases and liquids together are called as fluids. So these fluids exerts some pressure on some surfaces. So towards what direction do these fluids exert pressure, children? In general, fluids exert downward pressure, upward pressure as well as lateral pressure. So let us discuss one by one in detail with a few examples. So first of all, if you consider a downward pressure, what is meant by downward pressure? If you consider any liquid or a fluid. So for example, if you consider some amount of water in a container, then the whole weight of the liquid or fluid acts downwards. That means some amount of force is applied on an area of cross section at the bottom of that container. Force acting per unit area at the bottom of the container itself is called as, force acting per unit area is called as pressure. Force acting per unit area in downward direction is called as a downward pressure. Okay. So children, so let us revise the same once again. So what is all about fluids? So what are fluids, children? A substance which can flow from one point to another point. So, a substance which can flow from one point to another point is called as fluids. So, both gases as well as liquids can flow. So, both gases and liquids, as they both can flow, they both together are called as fluids. I hope you understood the concept. So, these fluids exert some pressure in direction. So, in which direction does this fluid exert pressure? These fluids can exert pressure in different directions. Especially fluids that exert pressure in downward direction is called as downward pressure. Upward direction is called as upward pressure. Whereas when fluids exert pressure sideways of the container, then they are called as lateral pressure. So let us discuss in detail regarding these three types of pressures. One is downward pressure, upward pressure as well as lateral pressure. First of all, moving to the downward pressure. let us consider some amount of fluid. For instance, let us consider some amount of water inside a container. So, in a container we have considered some amount of water. So, let us suppose that the mass of this container, the amount of water present inside the beaker, so the mass of the water be some m. So, the weight of the complete water acts in the downward direction. The weight of the complete water acts in the downward direction and its weight is given by mg. So, no doubt that this complete water exerts force in the downward direction due to its own weight. So, this water exerts some force on the bottom of the container. Okay. So, this force that acting on the bottom of the container in the downward direction itself, force acting on this given area itself is called as pressure. In which direction is it acting, children? This is acting in the downward direction. Hence, this pressure itself is called as a downward pressure. Similarly, let us also try to understand regarding the upward pressure. So, in the same type of liquid, let us also consider just So, now let us try to understand about the upward pressure. In order to understand the upward pressure, let us consider a small ball is immersed inside this beaker. Okay, let us consider that a small ball is immersed inside this beaker containing water. So, what we do is, let us apply some force on this ball and let us move inside the beaker. So, let us move this ball inside the beaker and now release. What happens, children? The ball immediately rises up. We have applied some amount of force on the ball to keep it inside and now we have released. The moment we release, the ball immediately comes up. So, what do you understand from this? This indicates that this water exerts some pressure on the ball in the upward direction. So, due to this pressure or due to this force on the surface, some force is acting on the ball in the upward direction. The force acting on the ball in the upward direction on that particular area of cross section itself is called as pressure, and this pressure which is acting in the upward direction itself is called as a upward pressure. So, this water exerts some amount of force on the ball in the upward direction. So, force is acting on this particular area. As a result, the ball moves upwards. So, this upward force acting on that particular area of cross section is called as a upward pressure. So, I hope you understood the difference between the downward pressure and the upward pressure. Downward pressure means the weight of the liquid. In other term, we can also say it as thrust. So, because of its own weight, thrust is acting on the bottom of the beaker, okay, on some particular area. So, that thrust upon the given area of cross section in the downward direction is called as downward pressure, whereas some amount of force acting on the ball when it is immersed inside the liquid in the upward direction, that force acting on that particular area in the upward direction is called as your upward pressure. Okay, children. So now let us also try to understand one more concept all about your lateral pressure. So what makes the difference between the lateral pressure, downward pressure and the upward pressure? Suppose if you consider a beaker. If you consider a beaker which is filled with some amount of liquid, so now to this container let us keep a small hole. So this beaker consists of some same amount of water, whatever we have considered in the earlier beakers. So now to this beaker what we have done is we applied a small hole sideways. When a small hole is applied to the beaker, then what happens, children? What do you observe? The water immediately starts coming out from this narrow hole. Okay, the water starts coming out of the narrow hole. So these are the walls of the container, as we know that the walls of the container. So because of that pinhole, a small hole that we have kept at the side walls of the container, the water immediately comes out and falls at some particular distance. So what makes the water to come out? Some amount of force is acting on the water in direction sideways. Okay, force acting side on some particular area in the sideways. So this sidewards force acting on that particular unit of area is called as your pressure, and the sideway pressure is called as a lateral pressure. So this is all about your lateral pressure. So what is lateral pressure, children? The pressure acting on the side walls of a container itself is called as a lateral pressure. So some amount of force is been acting on this particular area of cross section, and as a result, because of that narrow hole, the water comes out with some large force. So force on that particular area. So this pressure is equals to force on that particular area, and this pressure itself is called as your lateral pressure. So downward pressure, upward pressure and lateral pressure. So these are the three types of pressure you need to know, children. Similarly, you can also go with some more examples, children. Generally, you see that in sea and all, ships will be floating on. So how the ships will floating on? Whenever the ship floats inside the water exerts some upward pressure on the bottom of the ship. So that is an example of an upward pressure. Okay. So children, now let us try to understand the mathematical expression for pressure. Okay, inside the fluids. Next topic is all about the mathematical expression . Pressure inside fluids. To make you understand, in general, I am consider these fluids as liquids so that you can understand well. Okay, and mostly among those liquids, I am giving you example of water only. So what is the reason, children? So water, you can imagine, you can do the experiment, everything is visible. Which we consider gases means you have to imagine that. The real, you can't go through that. So that fluids means generally gases and liquids together are called as fluids. So in order to make you understand clearly instead of gases, I am giving an example of a liquids, that too specially water. Okay. So now, for this, in order to understand the mathematical expression for the pressure in fluids, again you have to consider a beaker, and this beaker is again filled with some water. Completely it is a water only. Excuse me. No other element is clear. So what you considered is, you have considered a beaker with some water. Okay. So no object is being kept. Let us consider that the density of this water be D. Wherever the point you consider, everywhere you have water only. Water is only taken inside the beaker. So density of water at every point will be same, and let us suppose that the density of complete water will be, some D. So among this complete water inside the beaker, let us consider a small portion of this water. Small portion, okay. So completely, so what I consider is small portion of this water, and let this be in some cylindrical shape. Small portion, okay. I'll consider something like this. You can understand in a better way. This is completely, you have water. Among the complete water, I have considered only small portion, and that portion also, what shape did I consider? Some cylindrical portion of the water only I have considered. So this is imagination. No outside object is being kept. A portion of water in the shape of cylindrical shape I have considered. Let us consider that the height of this big portion be some h. Depth, you can say it as depth. From top to bottom if you go, it is called as depth. Bottom to up, you will be considering L. Generally, for water, you will be considering it as depth only. If you measure the height of a person or a tower, then there you will be saying as height. But for water inside the container, you have to take it as depth for clarity. Okay. Let us suppose that the area of cross section of this cylinder be some A. What is the area of cross section? A. So what I have given you is that area of cross section as A, height of the portion, cylindrical portion of this water as H, and the density of the complete liquid is D. Does this water exerts any force or any thrust on the bottom? Of course, yes. Okay. So the force, this cylindrical portion of the water exerts some force on the bottom of the container. Okay. And that force is nothing but thrust. The force acting downwards, perpendicular direction, normal to the surface in the downward direction. The normal force acting on a given surface, okay, itself is called as your pressure. And this force is also called as thrust. This normal force is also called as your thrust. So whether you name it as force or thrust, it is due to its own weight. Okay, and this is given by the thrust or the normal force is equals to weight of the liquid, and it is given by mg. F is equals to mg or thrust is equals to mg. I hope the concept is clear, children. What is m? M is the mass of complete fluid in this cylindrical portion. But we know that from formula for density, we know that density equals to mass by volume. So if you bring this volume the other side, then we can write the value of mass as density into volume. density into volume will give you the mass of the liquid portion. So we can clearly write that mass, I'll write it as M, density I already named it as D, volume let us take it as V. Volume we have considered it as V. So mass can be written as density into volume. Let us replace the same here. So F is equals to, instead of mass I can write it as density into volume into G. So what is the formula, children? That force acting on the bottom of the beaker is given by dVg. So what is V here, children? Volume. If you consider this cylindrical portion, what is the volume of this complete cylindrical portion? As I have already given you the area of cross section of this as A and height as H. Then volume can be given as area into height. Volume is equals to base area into height gives the complete volume. So instead of volume, I can rewrite it as area into height. Area of cross section into height gives the complete volume. Area of cross section into height gives the complete volume. So F can be written as density into area into height. Instead of height we need to tell it as depth. Area into depth into G. So this is the force acting on the bottom of the liquid. So if F is equals to dAhg, what is the value of pressure? Because we want to find the mathematical expression for pressure inside the fluid. So what is the formula for pressure, children? Pressure is generally given as force upon area. So pressure is equals to, what is the formula for force? dAhg. Okay, and here you have A. So let us cancel A and A. Then you are left with pressure P is equals to dHg. Instead of dHg, I'll write H first, D next and G last. Okay, I'll write H first and D. So what is P here, children? P indicates the pressure, liquid pressure on the bottom. H indicates the depth. H indicates the depth, whereas D indicates the density of the liquid and G indicates the acceleration due to gravity. Hence, the mathematical form of pressure in a fluid is given by pressure P is equals to HdG, where H is the depth of the liquid, D is the density of the liquid and G indicates the acceleration due to gravity. So this is the most important formula you need to remember, children. Okay. So from this formula, let us discuss few more concepts. So if you observe that P is equals to, so what was the formula, children? P is equals to HdG. So H indicates depth, D indicates density and G indicates acceleration due to gravity. So as depth of the liquid increases, pressure also increases because pressure is directly proportional to H. So pressure increases with increase in depth of the liquid. So what I mean to say is, if I have considered large portion, large pressure will be acting. If I consider only small portion, then small amount of pressure will be acting. So larger the depth, larger will be pressure. Okay. Well, next. So as the depth increases, pressure also increases accordingly. Now let us come to the D. What is D, children? D indicates density of the liquid. So if the larger the density of the liquid, larger will be pressure. Lesser the density of the liquid, lesser will be pressure. So lighter liquids, lighter fluids have less pressure, whereas denser fluids have large pressure. So pressure increases with increase in density of the, here D indicates density children, H indicates depth, don't get confused, density of fluid. So pressure increases with the increase in depth, whereas pressure also increases with increase in density of the liquid. Always remember children, at a given point, pressure exerting from all sides at a given point is always same. Pressure acting at a given point will always be same. Okay, so pressure acting at a given point is always same. So one more point you have to remember. Okay, next one more thing children, pressure in all directions at a given point. Let me explain you clearly. So if you consider any point, the pressure acting due to the fluid from all direction at this point will be same. So in this direction, force upon this area, force upon this area, force. So pressure acting in all directions at a given points will always be same. Every direction you consider, same pressure will be there. Okay. So well, and one more thing you need to know children. Suppose if you consider some horizontal portion of the liquid. In this horizontal portion of the liquid, any point you consider, whether here, 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 everywhere the depth is same. Every point depth is same, H is same. Everywhere same liquid is there, so density of the liquid is same. Every point acceleration due to gravity is same. Hence, as HDG is same at every point on the same horizontal line of a liquid at rest, static liquid I can consider. So liquid which is not flowing. Okay, so at every point on this fluid which is at rest, the pressure exerted will be same. Okay, so let me write down the same children. Pressure at every point on the same horizontal line of a fluid. So is this fluid in flowing or in rest condition? Okay, so pressure is same at stationary. The fluid is in rest condition. Rest condition means it is stationary. So of a stationary fluid, rest condition, static condition, stationary condition is same. So pressure at every point on the same horizontal line of a stationary fluid is always remains same. Same horizontal line means same amount of pressure will be there. So in this formula you would have observed that the pressure acting at a given surface is independent of area. So nowhere we have considered area, because in this we have A got cancelled, so we can conclude that pressure does not depend upon the area of cross section. Whether the larger area of cross section or small area of cross section, pressure will be same. So pressure is always independent of area of cross section. Pressure is always independent of area of cross section. Whether whatever be the shape of the container, the pressure only depends upon the depth, density of the liquid as well as the acceleration due to gravity. So pressure is also independent of, pressure is independent of shape of the container. Pressure is independent of shape of the container. So these are the things you need to know all about your pressure. So what is the formula for pressure, children? Pressure is equals to HdG. So first point, as the depth of the fluid increases, pressure also increases. So pressure of a fluid increases according to the depth of the fluid. Pressure of the fluid also increases with the increase in density of the fluid. Pressure of a fluid on a same horizontal line remains same for a stationary fluid. Pressure is same in all the, pressure at every point on the same horizontal line will be same for a stationary fluid. At a given point, pressure exerting in all directions will be same. Pressure exerting in all directions at a given point will be same. Pressure is independent of area of cross section, whereas pressure is also independent of shape of the container. And one more last point you need to know regarding the pressure, children. Suppose if you want to consider pressure at some point, let us suppose that if you want to, this is the surface and from the surface, let us consider that sea level or something like this. Inside in depth, some liquid or fluid is there. And if you want to consider pressure at some point, so P. On the surface, it is open to atmosphere. Any pressure acting on the surface is always called as atmospheric pressure. And generally it is given as PA. A indicates atmospheric pressure. So, or we can also indicate the same as P naught. Someone indicate it as P naught, the others indicate it as PA. Where PA or P naught indicates the atmospheric pressure. So, because of the atmosphere, some pressure will be acting on the surface of the liquids. If you want to find out the pressure at some depth, let us suppose that the depth be some H. And if liquid density is D, then what is the pressure at this point, children? The pressure at this point, horizontal line, here, everywhere pressure is P. So what is the value of P? Generally pressure at any point P is given as HdG. Pressure at any point P is given as HdG. H indicates the depth, D indicates the density and G indicates the acceleration due to gravity. But already because of atmosphere, this is an open container. Because of atmosphere, some pressure is already acting. So along with this pressure, due to its own depth, some additional pressure is acting. So the total pressure acting at this point is PA plus HdG. If PA is the atmospheric pressure, then the pressure at a given depth is given by P is equals to PA plus HdG, children. This is also most important point. You need to consider that atmospheric pressure also. Okay. So